Oh, sorry that none of the recording up until now has any audio. So if you're just tuning into the recording, there's been 6 minutes without audio. I just realized that my mic was still muted.
Wow.
So not that we taught anything, but everyone's here anyways, right? 2, 4, 6, 8, 10, 12, 13. Yeah. Oh, you did miss me singing. Sorry, YouTube. That's probably for the better.
No, it's amazing. You should start a music channel.
I should start a music. You guys know I used to be in choir.
Oh no, we could have Calvin do his math rap.
Oh, Calvin,
And then
yes.
like you get so many hits.
All right, now hold up. So if I go back to my entry slide, what else do we know about a parallelogram? So all we have here is, okay, the lines are parallel. That's the first kind of like, duh, it's a parallelogram. But what else do we know, especially since Brian wasn't here yesterday? What can we talk about that makes a parallelogram specific? Megan?
Angle D and angle B are congruent and angle A.
Angle D and angle B are congruent. Angle A and angle C are congruent. What else can we say? Carmen?
Angle C and angle D are supplementary.
Angle C and D are supplementary, as
are B and A.
are B and A, as are B and C, as are A and C, which is also what works to prove why A and C are congruent.
You know what he means.
Yeah, sorry. If I tripped up, you know what I mean. But which proves why, I think this might be what you were just speculating, which proves why AC and BD are congruent with each other. Because if BC is a linear pair, or at least they are supplementary, and CD is supplementary, then based on substitution, I can prove that B and D are congruent. What else do I know? There's some really cool factoids about parallelograms also. Factoids, yeah.
Oh, we
Oh, I didn't know.
Wow, they only just have height and angle.
All right, my lines have a little bit of curve. Sorry, it's a smart board. Calvin? The diagonals bisect each other. So this length would equal that length, and this length would equal this length. Is there anything else that I know?
You have two lines.
Yeah, you have two parallel lines for the angles and the lines.
Yeah.
You need to make one for 4.
Those aren't parallel. Those are tick marks. Those are not arrows. They're just tick marks. Yeah, they're just for congruence.
Okay.
So I could have honestly started with a single congruence mark.
Okay.
But these are our parallel marks. These are our congruence marks. Megan?
Well, it's not labeled up here. Can I?
Sure. I don't care. I'm just reviewing quadrilaterals before we dive into the lesson because this will benefit us.
These angles are equal. These angles are equal.
Oh, so like alternate interiors then. So if we, and this goes kind of a step further, but if we look at this angle compared to this angle, they'd be alternate interiors, so they have to be congruent. But that kind of goes more towards our parallel lines or the transversal rule. That it's true that that works in a quadrilateral, but that's not because of the quadrilateral. Or sorry, that's not because of the parallelogram. That's just because the parallel line's in the transversal. So if we just have one transversal, that'll still be true, even if it's not a parallelogram. But I love that that you identified that. That's wonderful. Calvin?
Opposite sides are congruent.
Yeah. They didn't label it up here. So if I put a quadrilateral on the paper and I said, this is a parallelogram, label everything that would be labeled. They labeled that these are parallel, but they did not label that they are also congruent to each other. Same thing here. And then because I've already used 2 and 3, I guess I'll use 4.
Why'd you use 2 and 3?
Sorry. It doesn't talk about exterior.
I use my ones here.
No, I know.
Yeah, we can do.
This interruption. Avery Harrison, please report to the office. Avery, thank you.
We can do work with exterior angles too, but that we'd get really, really far down the rabbit hole if we kept doing that. So I love this. Wonderful. Thank you. Good review. So now on to our notes. So.
It's a bit chilly in this room.
Yeah, I like it. I heard Hall's room is even colder.
Oh, Paul's
I am a
room
switch
is
and I'm
frigid. It's honestly.
I wish my room was frigid.
It's either really cold or like
was
burning.
cold.
Yeah, I know.
This
Like
is
sometimes
unacceptable.
it gets really hot.
I was wondering that.
There was a few days it got hot.
I like today, but it's
started sweating in the
I
halls.
would
Your mom
run
would
like
like
80. Oh yeah, and it was freezing in there. No, but it's just the track house, like the but the actual temperature was 30.
Alright, now it's time.
What? Oh, I don't. So to clarify this again, especially since you guys are like the Math 2 class, I don't fight against like when the class does whatever. I just sit and wait because however quickly we get through stuff, that's more time for you guys. And the quicker we get through the material we need to, we do projects at the end of the year. So we do like I bring in bicycles and we do predictive projects. Like I've got projects that I've never gotten to do because we don't make it through our material quick enough. So if you guys want to disperse and chat for 5 minutes, whatever, that's just 5 minutes we can't use on other things. So now that I have your attention, definition of parallelogram, we know that. Theorem 45 is talking about the congruent opposite sides. Theorem 46 is talking about the congruent opposite angles and the supplementary angles. It actually is talking about the supplementary, which then proves the congruent angles. So theorem 47 is actually a derivative of theorem 46. Any questions on why we did this yesterday? But if I prove that these are supplementary and these are supplementary, then these have to be congruent. It just makes sense. Theorem 48 then talks about our diagonals being bisectors, and theorem 49 is talking about that one pair of opposite sides is congruent and parallel, which then the other side of opposite sides has to be congruent and parallel also. Mouthful. Any questions on any of those properties, which we pretty much just covered on our start slide? Muy bien. Muy bien. So, when we use this for problem solving, muy bien, very good. Ah, guapo. Jeez, hurt my feelings. Been trying to bike a lot lately. Doesn't guapo mean
It means handsome.
Oh. Well, thanks.
Wait, what did you think it meant?
I thought it meant
That's
gordo, yeah. So,
Did you just assume she like insulted you?
yeah, I mean, you guys are in middle school.
Well, we like you.
Problem 1. Thank you. Problem 1 here. When we know anything involving two variables, we always want to make our life easy and figure out how can I reduce it down to one variable. So relating PQ to SR, I can solve for the x value. And then because I know the x value, I can plug it into my PS and find out what the y value is. Do we have any questions on how they were able to do this process? So we can do the same exact thing with our angles, and we could either say that these two angles, H and G, are supplementary, but that would be difficult because that involves a y and an x. So we could also say that H and E are supplementary, which only involves y's. We could say that G and F are supplementary, or we could also relate that these diagonal angles are equal to each other. So I want you guys, you can pair up, probably pairs at most, because otherwise it gets too crazy. But I want to give you just a couple minutes to solve this in what you feel is the best way, because there are many right ways to get to Florida.
That's funny.
So same destination. If you guys have never heard me say this, we all have the same destination. There's one right answer. But there's a lot, especially the higher up you get in math, there are many, many correct ways to solve this. Some are very complicated. Some are more simple. So I want you guys to try. Right. I want you guys to try whatever you think is most efficient for solving for x and y here. You can pair up or you can do this individually. I'll give you about 2 minutes probably.
All right, by yourself. Let's do. Right.
12.
Wait, what? No.
I just solved it Tuesday on your shirt.
It's great.
Yeah.
No, how do we try to solve for E and H?
Tuesday
Or Y?
Plus,
Equals 180 minus 8 on both sides. And then you get 4.
okay. You guys work on your math. So I was just gonna get
172. Okay. Then you divide that by 4, and you get
No problem, bro.
I don't. Surprisingly. This is probably wrong. Yeah, I was just gonna guess it. That's what I've been doing on my own. It looks to be wrong. So salty.
All right. So, can we use the congruent angles? Okay, not can. Should we?
Not at first.
Not at first. Why?
Because both pairs of opposite angles have a y and an x.
Yeah, my pairs of opposite angles involve different variable values. So instead of relating my opposite angles, what'd you do, Calvin?
I said that angle H plus angle E equals 180.
So angle H plus angle E equals 180. So you can either write out the whole thing, or we're far enough that we can say, okay, 3y and y, that'll be 4y. Positive 10 and negative 2, what do those sum to? 8 equals 180 because they're a supplementary pair. Then we would,
4y equals 170.
yeah, we subtract 8 from both sides. So to get here, we took away 8, took away 8. And then we divide by 4, and you got, what was it? 43. Now, here's the thing that people always get confused on. Does 43 need an angle, degree symbol?
No.
Why?
Because it's going into a calculation that
Yeah, it's a
then
big.
that has the angle.
Yeah, it's not an angle measure, it's a variable value. So, since it goes into an angle measure, y itself does not need to have an angle measure. So how do I then use that to figure out my x? There's actually a pretty easy, there's a really easy way to do this. Ethan?
You do you take H and F are congruent, so you would put 43 in for y and H, add 10, and then you have one of the values, and then you just solve.
Yeah.
X.
As soon as I know my 43, exactly what Ethan just said, put my 43 in and then add 10, this angle is 53. So I know that really 4x plus 13 is 53, which when I subtract 13 from both sides, 4x is really 40, which makes x 10, and then I can plug that in. 10 times 12, 120 plus 7. This has to be 127, which I could have already figured out. And I know all of my angles. Do we have any, that doesn't look nice, do we have any other questions?
I got a different answer.
So what did you do? Did you get the same y as us, the 43?
No, I just guessed and checked, which was probably wrong.
Yeah, so we got to set up equations to solve it out. So
Now my homework's wrong, too.
Yeah, guess and check is not normally ever the best plan. So, the biggest thing is finding the angles in which you can use the same variables and then setting up what relationship they actually have. So, these have the same variables, they're supplementary. Or, these have the same variables and they're supplementary. So, I could have started by solving x first. There's no right or wrong way, as long as you get the right answer. Now, if you got the wrong answer, then you probably didn't.
Answer that works.
Well, not in the context of that problem, probably.
Well, yeah.
What'd you get for x?
1 and y was 7. I plugged
So
it
this
in.
would be 17,
Yeah.
and then this would be 1. That would be 19.
They don't add the 1. Oh, wait, they have to add 20. That's a good point.
So, did you just get it that it would work like opposite? Like they would be.
I'm gonna
Yeah.
go do my
So that's the dangerous thing. If you forget about one of the rules and you just worry about these are equal and these are equal, like you got to remember all of the rules. That's why all of this stuff's up here. Yeah. So refer back to there if you need. So problem 2 again. I like to start by giving you one solved out, but here we didn't because it's simple enough. Can we prove that the quadrilateral is a parallelogram? Parallelogram based on the given information. I'm going to zoom out. Yeah, I'm going to zoom out a tiny bit. So AB is 5, CD is 5. Angle A is 50, angle D is 130. Prove that ABCD is a parallelogram. What do we think? Yeah, we're trying. So the question, it's not, are we doing this? The question is, can we do
So like
this?
individually or like as a group? Okay.
Well, I mean, individually, I don't know where to start. Realize, by the way, like, I teach this class much different than most middle school classes. I very much teach this like a high school class. So there are often times where I say, I don't have any idea. I need like
My dad does that
that's
to me.
yes,
Oh,
that's
that
all
is
like
the most
yeah.
annoying thing ever. I'm sorry.
My dad
Really
does
I
that to me.
look, I know, but
Um,
that's just how like teachers have to
Yeah,
teach
I
to
know.
push you to figure it out. So I don't know, like we need to prove. So I know that A, B, and DC are equal lengths, so they have the congruence.
That's right.
And A and D are supplementary, so I mean that's good. But what else can we figure out, Caleb?
I'm not sure you can prove that it's parallel for the reason of it doesn't say that AB is parallel to DC. It doesn't say that BC is parallel to.
Now, I agree with you that it doesn't say it. But is there any other information presented that we could derive a parallel relationship from?
Because the two interiors are supplementary. Yeah.
Because angle A and angle D are supplementary to each other, they have to be a like pseudo linear pair. They don't actually share a line, but if
It's the
I took this up to here, then it's a linear pair. So that's kind of why I say it's a pseudo linear pair. They're disconnected supplements. So from there, Michelle, what do we?
You can conclude that DC is parallel to AB.
I agree, but there's one other piece of information that I have to like say again, Carmen.
Wouldn't you, or well, you would also be able to, will you be able to conclude that AB is congruent, or is parallel to DC, but then you, from that, you would prove that AD is congruent and parallel to BC, right?
Yeah, so actually, you were actually perfect with what you said. I was on the next step. So the first thing that we would say here is because A plus D, and this is really, really shorthand, but because A plus D is supplementary, then AB is parallel to DC. Then, after that,
Well,
Caleb?
you could also say now you could prove that it's a parallelogram because, well, this is, I don't think you necessarily need to know this, but you can prove that they're whatever. What do you, I don't know. How to say
Yeah,
it.
whatever.
What do you call it? Okay, It
Nice.
starts with a C.
complementary?
No.
Because nothing up here is congruent.
Maybe, I don't know. I was going to say, because then if you could find out the angle C, then you could find out the angle B, and if you knew all that stuff.
Now we can
Well,
only
I know
find
what
out
he's
angle
saying.
C once I know that AD is parallel to BC.
I know what he's saying.
What?
I know what he's saying.
Yeah, that's the word.
If I don't know that these two lines are parallel, I can't find this angle until I know that these are parallel.
Yeah, well, okay, then you would need to know that first part. But then once you found out that that's parallel, you would know angle C and B, and if they're the
But
same.
wait, back up. How do I know they're parallel?
Well, the stuff you just did up there.
This does not make me know that AD is parallel to BC. Right now, what blue shows me is that.
Alright.
What's written in blue shows me that.
Okay. I get where you're going with this. So you see that DC is a line. Can I agree?
Yeah.
Can I agree with that?
Yeah.
Well, with what you said with your whole pseudo linear pair thing, D and C have to equal 180 degrees. If I think I'm right.
Where are you going?
Why do they have
Yeah, 180 degrees. I think.
Yeah, they would.
Yeah,
but
they
we-
would equal 180.
Yeah,
Why?
but we don't know the angle.
Because you said the whole pseudo linear pair thing, where D and A, even though they're not actually a linear pair, are a linear.
interior angles unless you know that AD and BC are parallel.
No, you wouldn't know that
Well, then
because
how-
AB.
No, yeah, I think
Wait, can I
wouldn't
come up to the
angle
board?
D be a little
I was waiting for somebody.
Wouldn't it?
All right, so
It's so much easier in my head.
Not until you
if we
prove that
extend
AD and
this
BC are
and we
parallel.
extend this and we extend this, you know, like this. So you've got like your here, I'll blow it up. So it's like this, kind of, right? And so, if angle B is here, and then angle C is, C.
So here, I want to clarify something, just because I think there's a misconception happening. The reason I was able to see that AB was parallel to DC was the given angle measurements and the fact that the two given angle measurements were supplements. So the fact that you're thinking that angle C is a supplement to angle D, you don't know that. You haven't been told anything. So we have to have a statement that we do know for certain that ties it all together.
Oh, so it's not just about the whole if they. Okay, now I get it.
Because it's not what it looks like, it's what I see. Like what I am told, like mathematically what I see, not just what like my eyes think it looks like. Okay, so sorry, I just wanted to clarify that.
So since these are parallel, it doesn't matter because this line AD doesn't come into play for proving that angle C and angle B are supplementary. So you know what I'm saying, Michelle?
Wait.
So this would be
So if you like, so when we do the fancy thing that Mr. Hudson does, where he goes like this, except that one where like and then he like drags it there and then he flips around or whatever.
Yeah, it doesn't flip on this one.
Well,
I'm sorry.
you know, when it does like that and the C would go there and it would work, you know. So it would all work out.
There is
You're gonna
one.
error, Carmen, because you still don't know, because you would have to have the information. How do you know that, so basically I think what you're saying, right, is that this is like a corresponding angle with this? Or
No.
Okay, then no.
I'm saying we don't know the angle measures, but we know that they're supplementary. But we don't know like the measures of the angle
How do you know they're supplementary?
because of the alternate interior angles and then they're.
But how do we know that BC is at the same angle as AD?
Now I can name
What?
Well, I mean,
How do we know that the transversal BC is at the same angle as the transversal AD? This could be cockeyed.
Yeah, but it would still be like it might not like fit with this, but like we were like because they were fighting over whether or not these two were supplementary. And I'm
I
saying,
know. But that's my argument too, is how do we know that they would or would not be?
I think she's saying that basic and C are supplementary.
You broke it. All right. Ready for your mind to get blown? Go ahead.
Since
No.
the two parallel ones are congruent,
Thank
they
you.
both have.
He wasn't even here yesterday. Say it again.
Well, since the two parallel lines are congruent, then the angle has to be the same for the other two.
If I am already aware that AB is parallel to DC, and this transversal cuts through and makes endpoints, and I have another transversal that cuts through and makes other endpoints, and those endpoints are equidistant from each other, then the distance between A and B and the distance between D and C has to be the exact same thing, angle and everything. So because AB is congruent to DC, then we can say that AD is parallel to BC. Because I know the top and bottom are parallel, and then I see that they are congruent, that makes my left and right sides be parallel. Because of them being congruent. Guys, if we didn't know that these were 5, we'd be stuck. We could not move any further if I didn't have these lengths. So these lengths is what ties it all together and lets AD be parallel to BC. From there, we've essentially proved it. We can then tie it all together. We could say, because I now have these parallel relationships, these are supplementary pair, these are congruent with each other. We could go through that whole process and do the rest of the proof to say it's a parallelogram. But does it make sense? So here's the converse of what I was just saying. If those lengths weren't the same, you'd end up with something like this. So I love that you extended those lines out, right? So if I extended this line out and extended this line out, and they're parallel, but the line that comes through it, my secondary transversal, is not at quite the right angle, so that's not quite parallel, then this length on top would be longer than this length on bottom, because it angles up and covers more distance. Same if it angled in and covered less distance. So when I see those congruent lengths, that ties it all together. Caleb.
Alright, so I just have a quick question. For a parallelogram, if you know all the angles of a parallelogram, you still can prove it's like if you had all the angles of a parallelogram, could you prove it was like a parallelogram?
If they're
Yeah.
So if you forget about these,
Yep.
and those are not X's. Let's just say they look like Jesus fish. You've never seen the Jesus fish?
Yeah.
Except it's normally cuter
It
than
just looks
that.
like someone screwed up the infinity sign.
Yeah. So if you knew all of those, what could we then say?
Well, since they're the same angle, it'd be parallel.
Yeah, we can prove all the parallel relationships based off.
So if you knew these were parallel, you had a line going through it. Right?
Yeah.
You had that line going through it. You could say that the 130 angle was a corresponding angle to the angle next to C, and then since whatever what do you call them? Starts with an S. Yeah, but you could
It's supplementary.
supplementary. You can prove that one's 50, and then you could just do the same thing for the other side. So
Yep.
you wouldn't need to know that they're 5. All you just need to know is that.
But that's because I know all 4 angles. So yes, what you're saying is right, but if I don't know these angles and I don't know the lengths, I'm stuck.
Why would you need to know the lengths? Because if you had all 4.
because then that proves
But
the two are
Caleb, I'm saying if you're not given these angles, you are not allowed to assume what they are.
All right.
You have to be given at least one of them. Like if you were given angle B, then you could derive from there. Or if you were given both of these lengths or both of these side lengths, like we could derive it if we know anything of, but if we only know these 2 pieces of information, we're stuck.
Wait, but I said
those two prove that the other 2 lines, AD and BC,
Yeah,
are
but-
parallel.
Okay, no offense, I didn't have anything to do what I said. I was like, it was like a line, so it was like there was a vertical line and another line.
A
You can correct me
vertical
if I'm wrong
line.
here, yeah, and then draw another line through it.
Horizontal?
Yes, there you go. Right, well, and obviously we didn't draw that angle, but it's for simplicity's sake. So on the right side, the top right, just write 130, because we know it'd be a corresponding if we, oh wait.
That's right.
Alright, I was thinking really far ahead. You're right, never mind.
Hey, do you get what I'm saying
yes,
now?
Now I get it. Now I
Okay.
get it.
Sometimes it takes a little bit of processing through on your own. All good.
I got
All
it.
right, so I want you then to look at B for a minute. So now we know all 4 of our side lengths, right? And so Caleb, what you just proposed was if we know all 4 of our angles, so now we know our side lengths. That HI is congruent to HK, KJ is congruent to IJ. What do we think here?
What you're pointing, Caleb.
Carmen?
Okay. Well, so the it's not a parallelogram because the sides like opposite across from each other, they're congruent. But this it says the ones like right next to them are.
Nobody said that the opposite sides aren't congruent.
Ooh, that was exactly what I was about to say. Nobody said that HI isn't congruent to KJ.
So if this is a parallelogram, it's also a round.
Yeah, so if it's a parallelogram, it's going to end up being a rhombus.
But then when they put the same dash.
So what Calvin's saying? So Carmen said because these are consecutive and not opposite, it's not a parallelogram. But Calvin said, well, how do you know that this isn't the same thing as that? The 1 tick mark could be the same as the 2 tick marks, but we don't know that it is or isn't.
So wait, so one tick mark can be another tick mark.
It's not supposed to be.
Alright, so
they're
they're
like
just cheating
variables.
us.
Yeah, they are like variables.
Alrighty.
So the question is there anything I can do to prove or disprove?
No.
No.
Plus it looks really wonky, so it doesn't.
So is there any way that I could prove what Calvin wants us to say, that the 1 tick mark is equal to the 2 tick marks?
If you had
No.
measurements.
Yeah, if you had any
Angle
form.
line.
If you
But
had
that's
any-
not proof. Measuring something does not fall into proof.
No,
Knowing
because
a
if
length
you had
and
angle
relating based off geometric properties, that's proof. But if we measure something, that's not proof.
No, he means like
You
if
said
you
if we
had
had
measure-
angle
Oh,
measures.
you mean if I was given a measurement, yes. But right now, nope.
Nope.
I always like doing that.
Nope.
Work on the political office.
Impossible.
Oh, I could write a smiley face
Teardrop.
next to my veto something.
That's a beauty mark.
That's a mole.
So I can't draw a teardrop on here.
That's what you do.
It's very hard.
I keep you
Because
guys-
you have to
Make
make
a
it
really,
really
really
big.
shade to your mouth.
There you go.
Little friend.
All right.
That's interesting.
Does it make sense that there's just no information available to us?
Yes.
I would need to know actually, really, I would need to know 2 other pieces of information to really have a good start on this. So let's look at problem 2. I now see a pair of parallel and a pair of congruent.
Okay. Thank you.
So now I have a pair of parallel and a pair of congruent. So, what do we know about parallel lines that could help us here? Michelle? I hate, you guys get me all like, okay, they got an answer. Never mind. Brian?
Well, I think that G and D and E and F, they could be parallel, but they also could not be parallel, so you can't really know.
Okay, so thanks for telling me nothing.
You're welcome.
You stated information.
You-
Congrats.
You said what we don't know. No, I appreciate, like, he's just thinking out loud. They could be parallel. We don't know that they are. We need to derive some information.
I don't think that you can prove that
This
they're
image has a lot more information in it than what we see. We just have to derive the info. So I'm actually, we can see it over here. So I'm going to zoom in so I have a little bit of space to draw.
Wait.
Calvin?
I don't think you can because, like, one of the first things I do is see if I can disprove it,
Okay.
and like, if I can,
How are you able to disprove this?
well, couldn't you say that, like,
I know what I did.
since all you know is that they're parallel and they're congruent, you don't know that that's to scale? Couldn't you say that that could actually be like
What?
Well,
that,
no, he's technically right because
and it's not a parallelogram?
Yes, but I love what you said, and I've never thought of it like that, but yeah, you're totally right. But in order for math to work, we have to be able to trust what we're looking at. So I agree with we can't just trust what the image says because this could happen. We could have a trapezoid, a like regular trapezoid, where the 2 side legs are congruent and the top and the bottom are parallel, and they're not at all the same length. But here, we know that this is an acute angle. We know that this is an obtuse angle. Like, they're not going to make something look acute that is actually obtuse. It's not going to trick us that far. So I love your thinking. We can trust this image more than that. So that's a great thing to keep in the back of your mind. You can't just trust what it looks like, but here we can trust it enough to know this is acute, that's obtuse, whatever. Carmen, I forget my cycle, who I've called on when. I got to make cards, but yeah, Carmen.
Okay. If you would like extend, like let's say you extended DE, like if it like went like farther, then or what is that? Then FE would then have to be like a different length, like to like. Can I?
FE would have to be a different length.
So.
I think I know what you're saying. I was about to theorize this with you.
Wait, here, can I?
Sure.
Sorry.
I'd much rather have you do it than me do
So
it.
if like this, and then if, okay, wait. And,
killed the bug.
and then this went like farther, and like then this would have to be longer than this one to like account
Same
for.
thing with if it's shorter, so since they're
Yeah.
congruent, they
Yeah. So since it's congruent, these two have to also
I
like
completely agree.
be congruent because this isn't congruent. Yeah.
So, to summarize what Carmen's saying,
I erased this.
because DG is congruent to EF, and I already know that DE is parallel to GF. If DE and GF are parallel and DG and EF are not parallel, one of them has to be shorter or longer if they are not parallel. If they're not parallel, they can't be congruent. If they are congruent, they have to be parallel. Now, another way that we can derive this, here's where I would have gone. Because DE is parallel to GF, and GD is a transversal, or I can even just say is a line. I know it's a straight line. I then know that G must be supplementary to D. G must be supplementary to D because if GD is a straight line, corresponding interior pairs, or same side interior have to be supplementary. Does anybody have questions about what I just stated?
I got it.
Yeah.
I don't get what that does for us.
Okay, so G is supplement angle D. You're right. For, like, to start, that doesn't really do anything. We're just stating a relationship so that we have more information. So then, because I could state this later. It's just the first thing that I see. So we could have stated that second or third or something. So another because statement that we have is because DE is parallel to GF and GD is congruent to FE. Because these top lines are parallel and GD is congruent to EF, well, remember we said if they weren't congruent, if one was shorter or if one was longer, that would prove that they aren't parallel. So the converse of that is if they are congruent, they are parallel. So, based off those two relationships, GD must be parallel to FE.
But couldn't you say that without saying that G and D are supplementary?
Yeah,
Okay.
we could. So like I said, I could state this next, but if I want any angle relationships, I use that. Because then if I want to state all the angle pairs, I start with this, and then using my parallel statement, I can then relate that this is actually congruent because these would also be supplementary based off this parallel statement. These would also be supplementary. And then, based off my original parallel statement, these would be supplementary. And then I'd prove all the angle relationships too.
But that isn't required.
Yeah, you don't have to do it. But that's just more information that we can pull out and kind of identify. So, I believe I'm out of time. I believe I'm like beyond out of time actually. So, yeah, no, I'm right there. They're actually just missing like a minute early. So, the next problem is really easy, the one with the truck. The proofs are the ones that I wanted to take more time on. So, really, as Calvin keeps emphasizing, the red step here is the most important step. From there, the blue would just help us derive more information. Please, I'm going to open the wall. Please put your Chromebook away on your way out of class. And then you are all good.
And we're not doing 5 4.
No.